Right, so get this. The magnetic North Pole is shifting,
It is.
and it's moving faster than ever recorded.
Yeah.
What does that even mean for us? Could this shift actually impact things like our climate?
Well, that's a great question, and that's what we are going to uncover in this deep dive today.
All right.
Yeah.
We've got a stack of research,
Mm-hmm.
historical accounts, and some pretty wild theories to unpack.
It's a fascinating topic
Yeah.
because it really takes us from the depths of the Earth's core all the way out to the vastness of space.
Okay.
And we're talking about the Earth's magnetic field.
Right.
Generated by, this is amazing, a churning ocean of molten iron.
Okay, wait. Churning ocean of molten iron? That sounds like something out of a sci-fi movie.
It really does.
Yeah.
And within this molten core,
Okay.
you have these complex movements of iron.
Right.
There's something called azimuthal motion, which basically means swirling around the Earth's axis.
Okay.
And then there's radial motion.
Yeah.
Think of it as like in and out from the center.
Gotcha.
These movements generate electric currents,
Okay.
and that's what creates our magnetic field,
So that's the geodynamo in action.
the geodynamo.
But how does all this connect to the magnetic North Pole shifting?
Well, you can imagine a giant bar magnet
Okay.
inside the Earth.
Right.
That's a simplified way to picture the magnetic field.
Okay.
Now, the ends of this magnet, those are your magnetic poles.
Gotcha.
But unlike a fixed bar magnet,
Yeah.
the Earth's core is this dynamic,
Right.
swirling mass of molten iron.
Right.
As these flows shift and change, so do the magnetic poles.
So it's like the magnetic poles are dancing to the rhythm of this molten metal symphony
Yeah,
happening deep inside the Earth.
that's a great way to put it.
Yeah.
And lately, the music has gotten a bit more intense.
Okay.
The magnetic North Pole has been sprinting
Yeah.
towards Siberia
Okay.
at a rate of 50 to 60 kilometers per year. To put that into perspective, it used to move at a more leisurely pace of 10 to 15 kilometers per year.
Wow. That is a significant jump. And this is what has scientists buzzing, right?
Absolutely. It's this unprecedented speed that's raising all sorts of questions.
Okay.
The first one that comes to mind for most people is, how does this impact navigation?
Yeah.
After all, our compasses rely on the magnetic field.
Right. I mean, if north isn't where we think it is,
Yeah.
things could get pretty confusing out in the wilderness.
Exactly. And it's not just about compasses anymore.
Yeah.
We rely on GPS systems, satellite communication, even some animal migrations are tied to the Earth's magnetic field.
Wow.
So understanding these changes is crucial.
Okay, I'm starting to get a sense of the scale of this. We're not just talking about a compass needle wobbling a bit.
Right.
This has the potential to impact technology, wildlife, maybe even our understanding of the planet itself. So how do we even begin to unravel this mystery? I mean, it's not like we can just pop down to the Earth's core and take a look around.
You're right. It's not that simple.
Right.
But we have some incredible tools and techniques that allow us to peer into the heart of our planet and even travel back in time, in a sense, to understand the history of the magnetic field.
Okay. I'm intrigued. Where do we start?
Well, let's begin with a journey to the Canadian Arctic back in 1831.
Okay.
A young explorer named James Clark Ross set out on a daring expedition
Right.
to find the magnetic North Pole.
Wait, so someone actually pinpointed the magnetic North Pole?
Yeah.
I thought it was always moving.
It is always moving.
Okay.
But Ross was able to determine its location
Okay.
for that specific point in time.
Right.
He used an instrument called a dip circle,
Okay.
which measures the angle at which the magnetic field lines dip towards the Earth.
So it's like he took a snapshot of the magnetic North Pole's location.
A snapshot.
And what did he find?
He found it on the Boothia Peninsula
Okay.
in what is now Nunavut, Canada.
Okay.
It was a grueling expedition, facing freezing temperatures, navigating treacherous ice flows.
Right.
But Ross's discovery was a landmark achievement.
It really puts our modern-day GPS systems into perspective.
Yeah.
I can't imagine navigating the Arctic with only a dip circle.
Incredible feat of skill and determination.
Yeah.
But the story of the magnetic North Pole doesn't end there.
Okay.
Just a few years later, in 1845, another expedition set sail from England,
All right.
hoping to find the Northwest Passage
Okay.
and conduct further magnetic surveys.
Right.
This, unfortunately, is where our story takes a bit of a dark turn.
Oh, you're talking about the Franklin expedition.
The Franklin expedition.
I've heard about this. It didn't end well, did it?
No, it did not.
Yeah.
So John Franklin and his crew of 128 men vanished without a trace.
Wow.
The ships, the HMS Erebus and the Terror, were later discovered trapped in the ice. But the mystery of what happened to the crew lingered for over a century.
It's a chilling reminder of the dangers of Arctic exploration. But what's the connection to the magnetic North Pole?
Well, ironically, the Franklin expedition, though ending in tragedy, played a significant role in furthering our understanding of the magnetic North Pole's movements.
Oh,
The extensive search efforts
yeah.
that followed their disappearance led to one of the most comprehensive magnetic surveys of the Arctic region.
So even in their absence, the Franklin expedition contributed to scientific discovery.
They did.
What did these surveys reveal?
They provided further evidence that the magnetic North Pole was indeed moving,
Okay.
confirming what Ross had observed earlier.
Right.
But what's even more intriguing is that some speculate that the very magnetic anomalies they were sent to study
Yeah.
may have contributed to the ships becoming trapped in the ice.
Wow.
What a tragic twist of fate.
So we've got this elusive magnetic North Pole constantly shifting, leading explorers on these incredible and sometimes perilous journeys.
They were.
But what about the bigger picture?
Yeah.
How do we know that this shifting isn't just a recent phenomena?
That's where we turn to geology
Okay.
and the work of two pioneering scientists, Bernard Brunhes and Brunhes-Matuyama.
Yep.
Their research, conducted in the early 20th century, revealed something absolutely astonishing.
Right.
The Earth's magnetic field has flipped completely
Wait, what?
multiple times throughout history.
You're saying that north has become south and
Yeah.
south has become north multiple times?
Exactly. It
Yeah.
sounds crazy, but the evidence is there, hidden in rocks.
Right.
Brunhes, while studying volcanic rock,
Mm-hmm.
noticed something peculiar. Some of these rocks were magnetized in the opposite direction to what you'd expect.
So it's like these rocks have a memory of a time when the magnetic field was reversed.
Like a memory.
That's incredible.
Mm-hmm.
But how did they know these weren't just isolated anomalies?
Good question. This is where Matuyama's work comes in. He was studying lava flows
Mm-hmm.
and noticed a pattern.
Okay.
Layers of rock formed at different times showed alternating magnetic polarities.
So it wasn't just a random occurrence, it was a pattern,
A pattern.
repeating over and over again throughout geological history.
Precisely.
Wow.
And this pattern isn't just found in rocks.
Okay.
Further confirmation came from studying the magnetic striping patterns on the ocean floor.
Wow.
As new seafloor forms at mid-ocean ridges,
Okay.
iron-rich minerals align with the Earth's magnetic field at that time,
Yeah.
creating these stripes of alternating magnetic polarity. It's like a giant magnetic tape recorder of the Earth's history.
This is mind-blowing. So not only is the magnetic North Pole constantly shifting,
Yeah.
but the entire magnetic field has flipped multiple times
Multiple times.
throughout Earth's history. What does that mean for us? Could it happen again?
It's certainly possible. And that brings us to another fascinating chapter in this story.
Okay.
The discovery of the Van Allen radiation belts.
Okay, I'm ready for another twist in this tale.
Oh.
What are the Van Allen belts?
Picture two donut-shaped zones
Okay.
of highly charged particles that surround Earth.
Okay.
These belts are held in place by the Earth's magnetic field,
Right.
trapping radiation from the sun and cosmic rays.
So the Earth's magnetic field acts as a shield, protecting us from this harmful radiation.
Exactly.
Yeah.
And the strength of this shield is influenced by the magnetic field.
Right.
A weaker field, during a magnetic reversal, for example, could allow more radiation to penetrate the atmosphere.
Okay, that doesn't sound good. What are the implications of that?
That's a question scientists are actively trying to answer.
So we've got this intricate dance happening.
Yeah.
Between the Earth's core, the magnetic field, and even the radiation belts in space.
A lot to take in. Yeah.
It is a lot to take in, but let's step back for a moment and consider this.
Mm-hmm.
If the magnetic North Pole continues its rapid shift,
Mm-hmm.
or if the field were to flip entirely, what does that mean for us, for our technology, for life on Earth?
That's the million-dollar question, isn't it? And it's one that we'll continue to explore in our deep dive.
All right, let's do it.
Yeah. Let's delve deeper into those potential impacts you mentioned. We rely so heavily on technology these days,
Right.
and much of it is vulnerable to changes in the magnetic field.
That's a bit unsettling. What kinds of technologies are we talking about?
Well, for starters, satellites.
Okay.
They're essential for communication, navigation, and Earth observation.
Right.
But they're also highly sensitive to space weather, which includes things like solar flares and those charged particles trapped in the Van Allen belts.
And a weaker magnetic field during a reversal could mean more of that radiation reaching our satellites.
Exactly. This could disrupt satellite signals, damage sensitive electronics, and even shorten their operational lifespan.
So we're talking about potential disruptions to GPS, communication networks, even things like weather forecasting.
Precisely. And it's not just satellites at risk.
Mm.
Power grids on Earth are also vulnerable to geomagnetic storms, which are disturbances in the Earth's magnetic field caused by solar activity.
I remember reading about a massive solar storm back in 1859, the Carrington event.
Yeah.
It caused widespread telegraph disruptions and even sparked fires.
That's right. And if a similar event were to happen today, the consequences could be far more severe, given our dependence on electricity and interconnected grids.
So it's not just a theoretical concern. There's a real potential for disruption to our daily lives.
Absolutely. And it's not just human technology that could be affected.
Oh, right.
There's growing evidence that some animals, particularly migratory birds, use the Earth's magnetic field for navigation.
Wait, birds have a built-in compass.
They do.
That's amazing.
It is. They have these specialized cells that contain iron-rich crystals, allowing them to sense the Earth's magnetic field. It's like having an internal GPS system.
But if the magnetic field is shifting, wouldn't that throw off their navigation?
That's the concern. If the changes are gradual, they might be able to adapt. But rapid shifts or a full reversal could disorient them, leading them off course or disrupting their migration patterns.
Wow, so we're talking about potential impacts on entire ecosystems.
It highlights just how interconnected our planet is.
Yeah.
Changes in the Earth's core can ripple through the magnetic field, impacting everything from satellites in space to birds migrating thousands of miles.
It's a sobering thought. But is there anything we can do to prepare for these potential disruptions?
There are a few things we can do. On the technology front, we can design more robust satellites and power grids that are less susceptible to geomagnetic disturbances.
So kind of like building a stronger shield.
Exactly. And on the research side, the more we understand about the geodynamo and how the magnetic field behaves, the better we can predict and mitigate potential risks.
That makes sense. Knowledge is power, as they say.
It is. And we've come a long way in our understanding, but there's still so much we don't know. One of the big questions is, can we predict when the next magnetic reversal might happen?
That's what I was wondering. Is there some sort of magnetic doomsday clock ticking away?
Not exactly a clock, but scientists are using sophisticated computer models to simulate the dynamics of the Earth's core and the magnetic field.
So they're basically creating a virtual Earth inside a computer.
In a way, yes. These models are incredibly complex, taking into account things like the flow of molten iron, the Earth's rotation, and even the influence of the moon.
And what are these models telling us?
Well,
Can they predict when the next reversal might occur?
not with pinpoint accuracy, but they can give us insights into the conditions that might lead to a reversal and the possible timeline. Some models suggest that the current weakening of the magnetic field could be a precursor to a flip. But the timescale's uncertain. It could happen in a few thousand years, or it might not happen for tens of thousands of years.
So we're in a bit of a waiting game.
In a way, yes, but that doesn't mean we should be complacent.
Right.
The more we learn about the Earth's magnetic field, the better prepared we'll be for whatever changes the future holds.
Okay, so we're keeping an eye on the magnetic field,
Mm-hmm.
trying to predict what it might do next, and working on ways to protect our technology.
Right.
But what about those ancient pottery kilns you mentioned earlier? How do they fit into all of this?
The pottery kilns provide a fascinating window into the past behavior of the magnetic field. You see, when clay is fired at high temperatures, the iron-rich minerals within it align with the Earth's magnetic field at that time.
So it's like capturing a snapshot of the magnetic field frozen in time.
Exactly. And archaeologists have discovered that ancient pottery kilns from different time periods show different magnetic orientations,
Okay.
providing further evidence of the magnetic North Pole's wanderings and even those full reversals we talked about.
So even something as seemingly mundane as a pottery kiln can hold clues to the Earth's magnetic history.
It can.
It's amazing how everything is connected. But I'm still trying to wrap my head around the sheer scale of these magnetic reversals.
Yeah.
North becomes south and south becomes north. What would that actually look like?
What?
Would we see auroras at the equator?
Potentially.
Would compasses go haywire overnight?
It's important to remember that these reversals happen gradually over thousands of years, so it's not like a sudden switch is flipped.
Okay, so no sudden compass chaos. But what about those auroras?
Well, during a reversal, when the magnetic field is weaker and more complex, we might indeed see auroras at lower latitudes than usual. Remember, those dazzling displays of light are caused by charged particles from the sun interacting with the Earth's magnetic field. A weaker field could allow those particles to penetrate deeper into the atmosphere, creating auroras closer to the equator.
So a magnetic reversal might have some pretty spectacular side effects.
It could.
But what about the potential downsides? We talked about risks to our technology, but what about the impact on life itself?
That's a question that's sparked a lot of debate. Some researchers speculate that magnetic reversals could be linked to mass extinctions or other major biological upheavals.
Wait, are we talking about a potential extinction level event?
It's not that straightforward. The evidence is still inconclusive.
Yeah.
There's no clear correlation between past reversals and major extinction events. And remember, life on Earth has survived multiple reversals throughout its history.
Okay, so maybe not an immediate apocalypse, but still a cause for concern?
It's certainly something we need to understand better.
Yeah.
One theory is that a weaker magnetic field during a reversal could expose life on Earth to increased levels of radiation, potentially leading to genetic mutations or other harmful effects.
So we're back to those Van Allen belts and the protective shield they provide.
Exactly. And the strength and configuration of those belts could change significantly during a reversal. More research is needed to determine the potential biological consequences.
So we've got this magnetic field that's constantly shifting, a history of dramatic reversals, and a whole bunch of unanswered questions about the impacts on our technology, our wildlife, and even our own species.
Yeah.
It's both fascinating and a little bit frightening, to be honest.
It is a humbling reminder of the power of nature and the delicate balance that sustains life on our planet.
I'm curious, though, with all this talk about potential risks and disruptions, is there anything positive that could come from a magnetic shift or a reversal?
That's an interesting question. While there are certainly challenges to consider, there might also be some unexpected benefits. For example, a weaker magnetic field could potentially lead to new opportunities for space exploration.
How so?
Well, remember those charged particles trapped in the Van Allen belts?
Right.
They pose a radiation hazard to astronauts and spacecraft. A weaker magnetic field could make it easier to navigate through these belts, opening up new possibilities for missions to the Moon, Mars, and beyond.
So a potential silver lining in what seems like a rather ominous cloud.
Exactly. And who knows what other scientific discoveries might await us as we delve deeper into the mysteries of the Earth's magnetic field.
Well, after this deep dive, I'm certainly seeing the magnetic North Pole in a whole new light. It's not just a point on a map. It's a dynamic force that shapes our planet and influences life in ways we're only beginning to understand.
That's a great way to put it. And as we continue to explore this phenomenon, I have no doubt we'll uncover even more surprises along the way.
I'm ready for those surprises. So what's next in our exploration? We've covered a lot of ground in this deep dive, from the Earth's core to the Van Allen belts. It's been quite a journey.
It has.
But let's circle back to that question we posed at the beginning. Could this shift in the magnetic North Pole actually influence something as massive as our climate?
That's the big question. And as with many things in science, the answer is complex and nuanced.
Okay, but we love complex and nuanced here on the deep dive.
Good.
So let's unpack it.
What's fascinating is that while there's no direct cause and effect relationship that we can point to, there are some intriguing indirect mechanisms at play.
You're talking about those subtle connections we touched on earlier, like how a weaker magnetic field could allow more solar wind and radiation to reach the Earth's atmosphere.
Precisely. Even a small increase in solar energy could potentially nudge those delicate atmospheric circulation patterns.
And those circulation patterns are what drive the jet stream, right?
Yes.
That giant river of wind that circles the globe.
Exactly. So if the jet stream is being subtly altered by these magnetic field changes, it stands to reason that it could have some impact on weather and climate patterns.
Okay, I'm starting to see the chain reaction here.
Yeah?
Shifts in the Earth's core lead to a weaker magnetic field, which lets in more solar energy, which messes with the jet stream. And that can lead to all sorts of weather weirdness, heat waves, droughts, extreme storms.
It's a domino effect, and while we're still piecing together all the puzzle pieces, it's a compelling area of research.
It's like we're watching this incredible planetary drama unfold.
It is.
But it's a slow-motion drama playing out over millennia.
Right. A drama with a cast of characters that includes molten iron, invisible force fields, and even ancient pottery kilns.
Speaking of those pottery kilns, I love how they provide this tangible link to the Earth's magnetic past.
They really do. Each kiln, with its magnetic minerals frozen in time, is like a tiny time capsule telling a story of the magnetic field as it existed when that clay was fired.
It's amazing to think that something as simple as a pottery shard can hold clues to these vast planetary processes.
It speaks to the interconnectedness of everything on Earth, from the tiniest atom to the largest geological formations.
Okay, so we've explored the science, the history, and the potential impacts of this shifting magnetic North Pole and the possibility of a full magnetic reversal. What's the takeaway for our listeners? What should we be thinking about as we navigate this magnetically uncertain future?
I think the key takeaway is awareness. We live on a dynamic planet, constantly changing and evolving. And the magnetic field, while invisible to our eyes, plays a vital role in shaping our world.
So, paying attention to these changes, understanding the potential risks, and supporting scientific research are all crucial steps.
Absolutely, and perhaps most importantly, we should approach this with a sense of curiosity and wonder. The Earth's magnetic field is a reminder of the incredible forces that shape our planet and our place within the cosmos.
Beautifully put. And as we wrap up this deep dive, I can't help but think back to those intrepid explorers we talked about. James Clark Ross braving the Arctic to pinpoint the magnetic North Pole, and the tragic fate of the Franklin expedition, lost in pursuit of knowledge.
Their stories remind us of the human drive to explore, to understand, and to push the boundaries of what's possible.
And they also remind us of the power and unpredictability of nature.
It's a humbling thought, and it underscores the importance of respecting our planet and working to ensure a sustainable future.
Well said. To our listeners, thanks for joining us on this magnetic journey. Remember to check your compass the next time you're out exploring, and stay curious about the mysteries of our incredible planet.
Until next time.